The next big thing we need to wrap our heads around when it comes to database design is keys and dependencies. It's not too complicated, but it can be a little tricky when you're first learning it. So let's just take a look at a few of the topics that we're going to be dealing with today. We're going to look at what a primary key is, what a foreign key is, what a concatenated primary key, it's a big word there, concatenated, what functional dependency is, and then we'll look at the formal notation for formal documentation when you're writing up a document describing the tables and the primary keys and the fields and so forth. So first up, the three types of keys here. There's two types really, primary and foreign, right? The primary key is the main key that identifies a record, and then a foreign key is a field in a table that refers to a primary key in another table. A concatenated primary key is actually two different fields that will make up the primary key, and we'll look at examples of all this stuff. But as you can see here, a primary key, it's the unique identifier for a database record. The foreign key is a unique identifier for a database record in another table. Okay, and again, we'll look at examples in a moment. And then a concatenated primary key, it's a primary key that happens to use multiple fields. All right, the primary key or the foreign key, it's just a field in the table, or in the case of a concatenated primary key, it's multiple fields. All right. So a couple rules about a primary key. Number one, no duplicates. They have to be unique. The whole point of the primary key is to identify that specific record, much like your student number at the college or your social security number or something like that, or if you have an account with say, Comcast, the cable company or something, you have a unique customer number that is your number and nobody else's. All right. They are often you'll use an auto increment inside for your primary key, where whenever you insert a new record into the database, into the table, the value of the primary key will just automatically be created for you. In the current databases we use, it's not automatically created. We have to manually do it ourselves. But later on in the semester, we may take a look at how to auto increment. We may not, though. The last thing is when you create a primary key and you tell the table that this field is the primary key, MySQL will put a constraint on it. What I mean by a constraint, MySQL will not let duplicates occur, it will not let null values occur, and it will not let you try to reuse a number and so forth. So let's take a look here at the rep table, the towel rep table. What we're looking at here is, this is the formal notation. Now we talked about this in the last video. The only thing that we didn't do is the underlining here. This underlining refers to which field is the primary key. So in this case, the rep number, that is the primary key. It's a char2 type. It cannot allow nulls, and it is the primary key. Let's look at the towel customer table. Very similar idea, right? The primary key obviously is customer num, and again, it has the same restrictions. It's labeled as the primary key, and it cannot take null values. Item table. Same idea here, right? We're going to look at one that's a little bit different, but this is the primary key, and this is it right here, okay? Now let's go back and take a look before we get to the next one. Let's look at the customer table here. The primary key, as I pointed out a second ago, is this one. But there's also a foreign key. Now notice the foreign key it's not labeled anywhere, but the foreign key is actually right here. Why is this the foreign key? Well, rep num is actually the primary key of the rep table. So the rep num in the customer table is saying, hey, this rep num right here refers to the primary key of the rep table. All right. Now, at the moment, this being the foreign key, we know it's a foreign key because we're the programmers and we wrote it that way. But there actually is no constraint on the database right now that would enforce the rules of the foreign key. And we're going to learn how to do that towards the end of the semester, where we can put a constraint on there that enforces the rules of a foreign key. But right now, just when we write our queries, we know that rep key, that rep num is the foreign key. So we can use that to join up or to look into the rep table. Later, when we learn about constraints, we'll learn how to make sure that SQL will not allow you to enter a rep number in this table that doesn't exist in the actual rep table. All right, so back to the item table here. This one does not have a foreign key. There's no field in here that's referring to any field in another table. The next table, however, the orders table, okay, this one has a primary key, order num, right here, and the foreign key is the customer num. Again, this customer num is the primary key of the customer table. So in the orders table, whenever I'm referring to a customer num in this table, what I'm saying is, hey, this number is a number that exists in the customer database, in the customer table, and that number in the customer table is a unique identifier for that one specific customer. The last one's a little trickier. This is the order line table, okay? Now the order line table, you'll notice we have two fields that are underlined here. Because, and you'll see here that it says primary key for both of these. This is not two primary keys. This is one primary key, and it's called a concatenated primary key. In other words, by itself, the order number right here is not a unique identifier for this record. You might have it as an entry in your order line table, the same order number 10 times because that customer bought 10 different things, right? So if I had just the order number, I would not have one specific unique record from this table. If I had just the item number, same thing, I would not have one unique record because I could have 30 different customers order the exact same product. So I'd have that same product item number in there multiple times. However, the combination of the order number and of the order or of the item number, those two combined, you will never ever get more than one record. There will always be unique entries. If you combine the order number and the item number, it will always be a unique entry. Let's take a look at a diagram of the tile database. This is all 5 tables and how they're related to each other. And you'll notice they're all related from the primary key to the foreign key. So let's take a look here. And you'll see each one of these, there's the primary key. There's the primary key right here, right here. That little yellow light bulb exclamation point looking thing. Over here, you'll see 2 red ones. When you see more than one and they're red, that represents a dual or a concatenated primary key. It could be more than 2. It could be 3 or 4 or 5, but it's at least 2 to be considered a concatenated. Now, you'll also notice that we have the foreign keys right here. You see they have this little different colored diamond right here. And down here. And that's it, okay? Now, notice here that, yes, order num is a foreign key representing this primary key here, and item num is a foreign key that refers to this primary key over here. However, they, in this case, are combined to actually make the primary key, and so we don't really see them as foreign keys. They still technically are, however. And if you had a foreign key constraint applied to this database, to this table, then I would not be able to enter an item number that doesn't exist in this table, and I would not be able to enter an order number that does not exist in this table. The last thing to notice here is this. You'll see that each scenario here where I have this foreign key, you'll see that it specifically is linked right here to that primary key. Now, this is called rep num in the customer table, and it is referring to rep num in the rep table. However, this field here called rep num could be, it could be whatever you want. It doesn't have to be the same name as this. As long as you know specifically that this is the foreign key, and if you put a foreign key constraint on it, then it's being enforced by the database itself, or by MySQL anyway. But you don't have to do that. You can just name this whatever. I could have named this, instead of rep num, I could have named it Beavis. And I just know, because I'm the programmer, that Beavis maps to rep num in the rep table. Now, that'd be a silly thing to do, and it makes more sense to do it the way we're doing it. But a very common practice is to have inside the table itself, so inside the rep table, to actually not call this rep num, just call it ID, just the letters ID. And customer num would just be called ID. And order num would just be called ID. And item num would just be called ID. And so because in the item table we have something called ID, we make that we make that the primary key. It identifies the unique record. Then over here, I would still call this rep num. I would still call it rep num, but I would know, or maybe I would call it rep ID. That'd be a little bit more accurate. And then I would know that rep ID maps to just ID in the rep table. Hopefully that makes some sense. Let's take a look at some of this on the command line here, right? So let's get in here. And here we are. So I'm going to use the tile database and show the tables. There we go. So I'm in the tile database. And again, we have, if I look in, say, select star from rep. Sorry, yeah, we'll do rep. There are 4 reps, right? There's rep number 15, 30, 45, and 60. All right, if I, again, these select queries I'm writing, don't worry about anything I type on the command line. Don't worry about learning it or memorizing it or anything like that. I promise you, in about 2 or 3 more lectures from now, the rest of the semester will be all about the command line and all about these commands and all these queries. So for now, just sort of push the I believe button that you assume they work right. All right. Okay. So, and the I believe button is center of your forehead, in case you're wondering. All right. So next thing I want to do is I want to select just the customer name, actually the customer num, and the customer name, and the rep num from the rep table, from customer. All right, there we go. So remember, if I do describe customer, these are all the fields available to me: customer num, name, city, street, zip, rep num, so forth. I only wanted to look at just those 3 right there. Okay, so that's what I'm looking at right now. Now you'll notice there is this rep num field right here. This is in the customer table. And if you look at those values, you will see that they only match values that exist over here. 15, 30, 45. That's all you'll see. Notice 60 is missing, which means that Janet Sefton does not have any customers. That's basically what that means. We have not assigned any customers to her as a sales rep. So we can see very clearly that I don't have any values here that are not in here. Now, I could right now insert a record into the customer table that uses a number that's not in the rep table. I could do that if I wanted to, because I have not built a foreign key constraint yet. When I create a foreign key constraint, then MySQL will prevent me from doing that. But if I wanted to right now, let's just do that real quick. And again, don't worry about this command. Okay, so I'm going to insert into customer. We'll just put in a customer num, customer name, and a rep num. We'll leave everything else blank, and we're going to put the values of, for customer num, we'll put XYZ. Customer name is XYZ Incorporated, and the rep num we'll put 76. And it works just fine. And if I run that previous query right here, you will see I now have this new entry here, XYZ number 76. And you'll notice that even though 76 is here, it is not up here, right? It is not in the rep table. That's bad. That's dangerous. You could have somebody do a typo or accidentally put the wrong data in there. Later, towards the end of the semester, when we learn about a foreign key constraint, if I were to try to do what I just did, SQL would actually throw an arrow and would not let me do it. It would throw an error, not an arrow, right? And it would not let me do it. Okay, I'm going to remove that record I just added. So I'm going to delete from customer where customer num is XYZ. Get rid of that. All right, so we're done. All right. So again, this applies. Let's take a look at the select star from orders. Okay, here's the order table. Now remember, the customer number here, you can see that it has the customer number multiple times. There's a 126 there and a 126 there. We got 2 586s, 2 586s, and so forth. So there are a couple different places where that number's in there more than once. But the order number itself, which is the primary key, is not duplicated. It is never duplicated. All right, that makes it the primary key. This customer num is the foreign key, and any number here will be in this table here. All right, let's take a look at the order line. Select star from order line. Now this is one, let's look at the description of it real quick. Describe, why can I not spell today? Order line. Okay, describe order line. Now remember, this is a concatenated primary key. 2 fields together make up the primary key. And let's see that in action up here. If I scroll up here and look, This one thing alone does not uniquely identify a single record, right? In this particular case, it by coincidence happens to be, but it's not a guarantee. As you can see here, this number here, 51610, that does not uniquely identify this record because 51610 is also this record. So that cannot be the primary key. One of the rules of a primary key is that it must identify one and only one unique record. Now, if I try to use, say, the item number here, well, that doesn't work either. FD11 does not uniquely identify this record here, because FD11 also identifies this record. So the two of those are two separate records. There's FD11 that represents the first record there and also the second record. So that can also not be a primary key because it has to identify a unique record. However, the combination of any order number and the item number together, there will never ever be another entry in this table that has that as the order number and that as the item number. That together is unique, and it does uniquely identify this one specific record. And no matter how many records we put in here, this will never have duplication, assuming you're entering your data properly. And also, because it is a primary key, it will give you an error if you try to enter an invalid duplication. And I'll show you that in just a second in the code. So if you take a look, why is that the case? Well, an order number will have multiple line items on it, right? It can have multiple line items. Every line item will have a unique item number. So the combination of an order number and an item number uniquely identifies one line on an invoice. It uniquely identifies just one line. So hopefully that makes some sense. All right, now let's try to do a little insert here. And I want to insert into the order num table. So I'm going to insert into order line table is what I meant to say. Values. We'll say that the order number I'm going to try to duplicate something here. We'll go with 51608. 51608. And we'll do CD33. As you can see, I'm just duplicating this right here. Okay. And then after CD33, we'll do the quantity is 5, a number order is 5 there. I'll do the quantity order is 29, and we'll say the quoted price was $85. All right. This will not allow me to enter because this will make up the primary key, but the problem is that primary key already exists. You cannot have duplicate primary keys. And so we get an error. So hopefully seeing that on the command line a little bit and looking in the tables directly and seeing some of the data kind of helps clarify some of this primary key stuff. So let's head back to PowerPoint presentation here. All right, now we're looking at the colonial guide table. So my question for you is, what is the primary key? Take a moment and pause the video and see if you can take a guess. The answer is guide num. What's the formal notation? Again, pause the video and take a stab at it. Survey says that mess on the screen right there. I'll let you read it. Okay, but notice it's just the name of the table, which is guide, right? This is the guide table, as I pointed out right up here. And then the primary key, since we know it's the guide num, that's the one that's underlined. And then all the rest of the fields are listed there. All right. Take a look at this one, the trip guides. What is the primary key? Pause the video, take a minute to think about it. And the answer is trip ID and the guide num. It's both. It's a concatenated primary key, and you can tell that by looking right here where you see two of them labeled as primary key. There is no such thing, listen carefully, there is no such thing as a table that has two primary keys. So if you see primary labeled twice in a table, that means that is a concatenated primary key. If it's just two like that, then it's a dual primary key. If it's three, call it a triplicate primary key. But whatever it is, it's one primary key that's made up of multiple fields. Again, there is no such thing as a table that has more than one primary key. It's only if you see more than one labeled like that, it's because they're all combined together to make the primary key. All right, enough beating a dead horse there. Next question. Again, what's the formal notation? Pause the video, take a minute, figure it out. The answer is trip guides, because that's the name of the table. In parentheses, both fields are underlined because they both make up the one single primary key. Let's take a look at the relationships here again. Notice, again, we have the guide num primary key, customer num primary key, reservation ID, trip ID. All right? Those are the primary keys, and then these two combined are a primary key that are made up of this trip ID foreign key and the guide num as a foreign key. So those two foreign keys together make the primary key. You'll also see that this customer number here is linked to the customer number foreign key. Customer num is the foreign key for this table, which refers to the primary key of this table. Let's take a look at the Solmaris database and its relationships. So these are all 5 of the tables here. Take a close look at it, and I want you to answer the question on the right there: which tables have concatenated primary keys? Take a moment to think about it. Pause the video. The answer is none of them. None of them. How can we tell? Well, if you take a look again, when there is a concatenated primary key, you will see 2 of those little exclamation point looking things, but they'll both be red or some other color depending on the tool that you're using. But this particular tool, that's how we tell. And you see that nowhere do we have more than one thing labeling a field as part of a primary key. So there are no concatenated primary keys. Okay, next question. What are the primary keys? I kind of gave that away a little bit there, but go ahead and pause the video. Make sure you know what the primary keys are. Survey says category num, service request, service ID I should say, condo ID, owner num, location num. Next question, what are the foreign keys? Take a look, pause the video. The answer is category num. Now that's one I didn't point out a minute ago when I was talking about foreign keys and primary keys. Category num is the foreign key in the service request table that points to the category num in the service category table. Category num right here is the foreign key here that points to the primary key right here. All right. Next one, the location num. And again, the location num, there it is. That is the foreign key of this table, which is referring to the primary key of this table. Next one, owner num. So look at this particular table. It has 2 fields that are foreign keys. That's totally legal. You can have 20 foreign key fields. It doesn't matter. But again, what we have here is this is another foreign key in this table that refers to the primary key in this table. Next, we have the condo ID. Once again, we have another foreign key here in the same table. So that foreign key is in this table, and it represents the condo ID, which is the primary key of this table. And that's all the foreign keys. So the next big idea, now that we have our head kind of wrapped around this idea of foreign keys and primary keys, we need to talk about functional dependency. But I want to clarify one thing before I do that I just thought of. When we're talking about these scenarios where you have 2 foreign keys in one table, that is not, I repeat, that is not a dual, or I'm sorry, that is not a concatenated foreign key. That's not a thing. You don't have concatenated foreign keys. You can have concatenated primary keys, but when you have multiple foreign keys in a table, it's just that. It's just multiple individual foreign keys that refer to a bunch of different tables. Primary keys that are concatenated, however, there's only one primary key. And if you have two fields labeled as primary key, they work together to be the concatenated one single primary key. So hopefully that makes some sense. All right, next up, functional dependency. Functional dependency is simply, the best way to put it is right there on the screen. It's any single field that can be determined by knowing another single field value, right? Any field that can be determined by knowing another single field value. All right, let's take a look at how this plays out. Here's an example. The last name in the rep table is functionally dependent on the rep num field. So in other words, if I know the rep num ID, if I know that number, then automatically I know the last name. So if we take a look at that in the code here, use tile, and I'm going to say select star from rep. If I know 15, then I can know everything about whoever 15 is, because there is no other 15. So every field here, each one of these individual fields, the data in there is functionally dependent on the rep num. Each one of these is functionally dependent on this field right here, the rep num. Generally speaking, you'll find that all the fields in a table are functionally dependent on the primary key. Okay, we'll talk about some more details in a moment, but that's the big picture right there. So if we go back to the slide here, we can see that in that case, the last name is functionally dependent upon the rep num. If I know the rep num, then that gives me one single unique field value, well, I should say record, right? So any single field value that can be determined by knowing another single field value. So every single one of these, whoops, let's go back to here. Every single one of these, each field, right? That field can be determined, or that one, or that one. Anything in there can be determined by that. Okay, hopefully that makes some sense. All right, next up. Again, we could just see the table there, and I just kind of walked through that on the command line, but there's another shot of it for you right there. Every single field individually is functionally dependent on the rep num. Okay? So let's ask this question. Is last name functionally dependent on first name? I'll pause the video, let you guys think, or you pause the video and think about that one. And the answer is no. It actually is not functionally dependent. Why? Let's take a look at this for just a minute. Let me back up here. What I have right here is the database as it exists. Okay. Now, right now you'll notice that nobody has the same first name, nobody has the same last name. So you could argue that if I knew the first name, so if I knew Raphael here, then therefore I would automatically know Campos. Well, yeah, in this one little piece of data, that is true. However, if it were to remain true for the lifetime of this table, then we have a problem, because someday we may hire another employee named Raphael, right? Someday we may hire another Megan or another Janet or another Hoy or something like this, okay? So you cannot say that the first name, that the last name depends on the first name. That is not true. If that were the case, then every single pairing of first and last names would be unique, and there would be no such thing as the same first name in the database ever, all right? And that is obviously not the case. As you can see here, if I were to, I give you the answer here as being no, but look what I did. I added somebody named Janet Jackson. She lives on a different street. She's not related to Janet. She has nothing to do with Janet. She is not Janet. And now if I know the first name, does first name automatically guarantee that I will get one single unique record? And the answer is no, because first name would give me this record or this record. Now, don't be fooled by looking at a table that looks like this. Just because there are no duplicate first names there does not mean that first name is depends on last name, or that last name is dependent on first name. Okay, I said that backwards the first time. It doesn't mean that last name depends on the first name just because there's no duplicate records. Because the rules of the company and the rules of the table are such that you can have more than one first name. You can only be functionally dependent on a particular field that cannot have duplicates. All right, hopefully that clears that up. Okay, let's take a look at the next thing. Here's the formal notation for writing up functional dependency. What we're saying here, rep num functionally determines last name. Okay, so we're saying it a little bit differently now. Rep num functionally determines last name. Rep num functionally determines first name and street and so on down the line. So the thing on the left functionally determines the thing on the right. Okay? For those of you who are familiar with conditionals and propositional logic, if you're not, just ignore what I'm about to say. But if you are, you can kind of look at this like a P therefore Q type of a statement. If we know rep num, therefore we know the last name. You can think of it kind of like that. That metaphor breaks down a little bit. And if you're not don't know propositional logic, just ignore all that. But the idea here is that the thing on the left functionally determines the thing on the right, or the thing on the right is functionally dependent on the thing on the left. Remember our wording over here on the previous slide. We were saying that last name is dependent on rep num. Or we could say it the other way, that rep num determines last name. Okay? So this is how you formally notate that. This is, again, just me repeating how to speak it. You say rep num functionally determines rate, or you could say rate is functionally dependent on rep num, or you could say rate is functionally determined by. Right? All of those are the same thing. So take a look at that just for a moment. Make sure it makes sense. Make sure you understand that. Okay? We're claiming that the rep num determines XYZ field, or we're saying XYZ field is dependent upon or determined by rep num. Let's take a look at the TAL item table, the TAL database item table. The question is, where is the functional dependency? Pause the video for a moment and take a guess. Not a guess, an educated assessment. Let me put all the questions on the screen for you first, and then I'll have you pause the video. So there are all the questions. What is quoted price functionally dependent on? What's number ordered? Item num, order num. What are each of those functionally dependent upon? All right, the first one. What is the quoted price functionally dependent upon? The answer is order num and item num. Not item num, not numb. Order num and item num. Why is that the case? Well, if I know a unique order num and item num, if I know those two values, then I will get one specific field. Pick any one. If I get those two specific values, I will know I didn't mean to square that one. Let's try that again. If I know, just say these two here, then I am guaranteed to know that number and that number only. Any case where I know two specific numbers that are in this table that are paired together, if they exist. For example, 51625 paired with TR40 does not exist, okay? But 51625 paired with MTO3 does exist. So that primary key right there, if I know that, then I definitely know that and only that value. There is no other quoted price that this pairing can lead me to. So what is the number ordered functionally dependent on? Well, take a look here and you'll find it's exactly the same thing. By the same logic I just pointed out, that if I know any given pair here, then I am able to determine everything in that record and only that record and no other record. All right, next up, what is item num functionally dependent upon? And the answer is nothing. Okay, it's functionally dependent on nothing. The reason being is there is no single field that if I knew it, I would automatically know the item number. In other words, just because I know 51610, that does not guarantee that I will know one specific individual item number. Because 5160 might mean that item number or that set of data, or 51610 might mean that set. So item num cannot be dependent on order num because there's not a unique single individual order num. So because item num happens to be part of the primary key, then it's not dependent on anything. So next question, you may have guessed by now, what is order num dependent upon? And the answer is also nothing for the exact same reason. There is no single field value that if I knew it, I would automatically know the order number. Now, you could argue that by looking at these values here, They're all different. I don't see any duplicates there. I could be wrong, but I'm not seeing any duplicates. So you could argue and say, hey, if I knew 29.95, then I would automatically know that order number. Well, by that logic, that would mean that in the future, no customer ever could ever have an order totaling to 29.95. Only this one order for this one customer, and that's it. You can never ever again have a 29.95 order. And obviously that's a bad business rule, right? So you have to keep in mind the functional dependency is not based on the data in the table. It's based on the structure of the table, right? And what's the structure? The structure is such that if I wanted to know this individually or this individually, there is no other field in this whole table that could tell me that one thing. That if I knew one field or another field or whatever, that I would then magically know this one. There's no such a thing for these last two right here. So our plan for the day was to take a look at what is a primary key. I think mission accomplished. What's a foreign key? Also mission accomplished. What is a concatenated primary key? Mission accomplished. What is functional dependency? Mission accomplished, I think. And formal notation. Those are the 5 things I wanted to focus on. Just a brief recap. A primary key is either one field or a series of fields combined to equal one specific unique identifier for one specific unique record in the table. A foreign key is a field that in the table that it's in refers to a primary key in another table. The reason it's called a foreign key is because it's not really part of the data in that table. It's not really part of that particular data set. So in other words, what I mean by that is, let's look at the customer here. Select customer num, customer name and rep num from rep. Typo there. Sorry, that should be from customer. Okay. So what's happening here? Yeah, rep num is in the table, obviously. Rep num is in there. But rep num is the rep is not the customer. This is not the part of the customer. It is foreign to this table here, right? Rep num is foreign to this table. It comes from a foreign land known as the rep table, right? That's a way to think about it. So it's a foreigner from the rep table that's made its way into the customer table, and it's part of the customer table. That's how it gets the name foreign key. All right. Concatenated primary keys, again, it's 2 or more keys together, 2 or more fields together that make a concatenated to make a primary key. Functional dependency, again, it means simply that if I know this one particular field or these 2 particular or X number of particular fields, then by definition I can know one specific value of every other given field in the database, in the table. So again, take a look at the rep table here. If I know this one specific value, if I know any one given rep, then I can know any one specific last name, any one specific first name, any one specific street, and so on down the line here, right? Because there will never be a duplicate, because that is the primary key. So everything is functionally dependent on the rep num, or the rep num functionally determines all the other fields. And then the formal notation. We looked at that. If you want to see that again, you can back up a couple of slides and you'll have that. So that's it. Hopefully that clears up some details about keys and dependencies. See you next time, folks.